Hey everyone, welcome back to Abstract Synthesis, a podcast by AGI Research Lab and DIA. I'm your host, Brian Landers. This week we're going to have a bit of a change of pace. We're going to do a mini episode to sort of zoom out and reflect on what we've learned so far on the podcast. Now, I haven't said it yet so far, but if this incredibly niche AI podcast is your jam, hit subscribe, jump into the comments, ask questions, suggest future guests. Definitely want to hear your thoughts. It'll help shape the future of the show and just make sure we're making content people like. All right. So over the last 8 episodes, we've covered quite a wide range of topics. We've covered grammar filtering, non-monotonic reasoning, inductive logic programming, temporal logic, vision language programs, and symbolic world models. Now, just to recap, program synthesis, the main focus of the podcast, is the problem of automatically generating code that satisfies a specification. And at a high level, all of these solutions and approaches we've been exploring are grappling with the problem of search. You're searching over programs, rules, behaviors, or models that satisfy some specification. But what we hear again and again, though, is that unconstrained search is pretty much impossible. The search space just explodes too quickly. So the real question is not how do we search faster? It's how do we make the relevant parts of the search space searchable at all? And what we've heard on the pod so far points to that being much more about representation, bias, and structure than about clever algorithms. Now, I want to share 3 emergent themes to reflect on. Theme 1. Shrinking the search space without breaking correctness. Now, in the episode about grammar filtering, Mark Santalicito's big insight wasn't, let's go use ML to guide synthesis at runtime. It was instead, can we remove parts of the grammar before synthesis even starts? In inductive logic programming, ILP, Andrew Cropper made a similar point. Progress doesn't come from making the learner more clever, but from learning constraints as opposed to, adding them by hand, that rule out a ton of hypotheses up front. My teammate Celine Haquette's work pushed that even further. Instead of tuning the learner or the solver, she changed the problem representation, decomposing examples into relational facts, so the system never has to consider long, brittle chains of reasoning in the first place. So the common thread here is important. Speed-ups don't always come from smarter search. They can come from pruning regions of the search space that can't produce solutions. Oh, and notably, these constraints aren't heuristics. They're principled. They preserve correctness. Correctness meaning synthesized programs are provably guaranteed to satisfy its formal specification. Theme 2, why correct programs still behave badly. In the episode with Kedar Namjoshi from Bell Labs, we learned that logical correctness isn't enough. Traditional specs are fantastic for verification, but for synthesis, they allow way too much. Sure, the system does exactly what you asked, but then it goes and does a bunch of other things you did not want, and maybe that even have negative, real-world outcomes. Monotonic logic, if you remember, is where you can add new rules or assumptions that will never invalidate conclusions that were previously derivable. But once you say, don't do these unnecessary actions, you've left the world of monotonic logic. You're now reasoning about preferences, minimality, and trade-offs. I think we can see a parallel idea in symbolic world models. In Top Kyriakokij's POE world, instead of learning one giant model, the system learns many small causal programs, each with a weight that effectively says how much we should trust it. So behavior emerges from composition, not optimization against a single objective. So there's kind of an important shift happening here, which is synthesis is moving away from find a correct program toward find a reasonable one. Theme 3, the real meaning of neurosymbolic. Now, a lot of people hear neurosymbolic and imagine some kind of fuzzy hybrid where we perfectly merge, intuition and analytical, system 1, system 2 thinking. But that is not what most of the systems we're seeing are doing. For example, in the LTLF episode with Moshe Vardi, it's a linear temporal logic over finite traces. The finite traces simplify the symbolic reasoning so much that synthesis becomes practical again. In the episode with Antonia Wust about vision language programs, we saw neural models aren't doing reasoning, they're doing perception. They ground models, and then the reasoning bit is done with symbolic methods. So what's emerging here is more like a division of labor. Neural systems handle messy, ambiguous inputs. Symbolic systems handle structure, constraints, and guarantees. Maybe an interesting research question is deciding where that boundary should live. All right, so that's a short recap of past episodes so far. Stay tuned for so much more. We're talking with some amazing researchers who will join me on future episodes. It's going to be amazing. And again, jump into the comments, leave ideas for future guests, ask any questions. We'd be thrilled to hear from you, and make sure you subscribe if you're enjoying the show. See you on the next episode of Abstract Synthesis.